In this video, I'm going to be going over dimensional analysis and how to set up the dimensional analysis problems that we see so often in chemistry. Right now, because we're just learning dimensional analysis for the first time, we're just going to be using it to do some basic unit conversions, but there are actually a lot of times where we will be using dimensional analysis throughout the course of the school year. So this is really just meant to teach you how to do the setup. So even though you probably know how to do unit conversions already just from past classes or from math class, make sure you have a good grasp on how to set them up for this class too, using dimensional analysis. So to start off, I have a whole bunch of conversion factors listed up here at the top. These are examples of conversion factors. A conversion factor just gives you the relationship between two units. So for example, 1 inch is equal to 2.54 centimeters. That's the relationship between inches and centimeters. These are usually going to be things that you just have to look up or you'll be provided on a table. So the first problem here says, how many inches are in 4.65 kilometers? So the first thing you always want to do is just like set up the horizontal line down the middle. This is going to be where we are setting up the actual dimensional analysis. So this is one thing I will be looking for when you are setting these up, is that big long horizontal line. The number that is given to you in the actual question itself, 4.65 kilometers, is going to go here in the top left corner. And then I'm going to separate it from my first conversion factor with the vertical line. Okay. When you are setting these problems up, really we need to think about how we can convert kilometers to inches using the conversion factors that are given to us. So let's see, what do I have? I am given miles to kilometers right here. So I could change kilometers to miles. Then I could change miles to feet, and then feet to inches, and that would leave me in inches. So I'm going to write down that plan over here off to the side, and if this is helpful to write this down every time you do one of these problems, then that's fine. So I'm going to go from kilometers to miles, miles to feet, and then feet to inches, and that will give me the correct answer. Right. When you are setting up the conversion factors, you always want to set it up so that the unit you are trying to cancel out, kilometers, goes on the other side of that long horizontal line. Because kilometers started out on the top, to get it to cancel out, it actually has to go on the bottom. So you can see how km is on the top right here, but it's also on the bottom down here. That means it's going to cancel out when I finish writing the conversion factor. Okay, miles goes up here because that was step 1, is to change kilometers to miles. And my table above says that 1 mile is equal to 1.609 kilometers. All right. So kilometers cancels out because it was on the top and it was on the bottom. And then I can move on to the next conversion factor. Okay. The next conversion factor, I have to change miles to feet. Miles is on the top currently, so to get miles to cancel out, I'm going to put it down here. And then feet would go on the other side. 1 mile is equal to 5,280 feet. And then finally, changing feet to inches. Feet has to go on the bottom, inches on the top. 1 foot is 12 inches. Like that. All right, so you can see here the only unit that is left that is not canceled out currently is inches, and that means my final answer is going to have units of inches. That's how you do the setup. Now to plug this into your calculator and get an answer, you're going to start with the number at the beginning of the problem, 4.65, and you're going to go across left to right. Anytime you have a number in the bottom, you're going to divide by that number. Anytime you have a number in the top, you're going to multiply by that number. So this is going to be what I plug in my calculator. 4.65 divided by 1.609 times 5,280 times 12. And you don't even have to hit equals in between those. You can just put the whole thing in your calculator and the correct answer will come out. And what I got was 183,110 inches. As far as significant figures go, I just round based on that first number that I had, 4.65. So I'll just say 183,000. Like that. And that would be the final answer. Okay, so that's how you set these up. Really, it's just a matter of figuring out how to get the units to cancel out to give you the desired unit at the end of the problem. And you can usually set these up in more than one way. There will typically be more than one way to do this. So for example, in that last question, I could have changed kilometers to meters, and then meters to inches. That would have been fine too if I knew the conversion factor between kilometers and meters. I just used the ones that were in the table to make it a little bit easier. All right, next one, convert 14.5 miles per hour into kilometers per week. The units on this number that I'm converting, miles per hour, that is a little bit more complicated than the last example. When you have units like that, where it's one thing divided by another thing, the easiest way to approach those problems is actually to separate those units the same way across that horizontal line at the beginning of the problem. So instead of putting miles per hour in that whole top spot, I'm just going to separate it like this. So miles is on top and hours is on the bottom, just like it is in the unit. This is going to make it easier to convert hours into weeks. If I didn't separate it, if I had it all up in the top left with the rest of the number, it would be kind of hard to figure out how to cancel that out. All right, so I really have two goals in this problem. I have to change miles into kilometers, and then I also have to change hours into weeks. This is sort of two problems in one. To change miles into kilometers, that's actually pretty easy because we have the conversion factor for it up here at the top. I'll leave it highlighted. 1 mile is 1.609 kilometers. Okay, so you can see here miles cancels out, kilometers is left on top, and that's what I wanted to be in the top of my unit. So I'm actually done with that half of the problem. The next thing I have to do is change hours into weeks. So to do this, you have to think, how can I convert hours into weeks? You probably don't know off the top of your head how many hours are in a week, but you do know how many hours are in a day. So I'm going to start there. 1 day is 24 hours. Notice when I set that up, because I wanted hours to cancel out and hours was at the bottom initially, I put hours on the top in the conversion factor. So you can see hours is on the top over here. It's in the bottom at the beginning, so hours is canceled out. All right, so now I have kilometers per day. To make it kilometers per week, I need to change days into weeks. And that is not too difficult of a conversion. 1 week is 7 days, okay? So days cancels out and I'm left with weeks. If you take a look at the units that are left, I have kilometers on the top up here. That's the only thing on the top that's not crossed off. And then I have weeks on the bottom down here. That means my final answer is going to be kilometers over weeks. I'm going to plug this in the same way I did the last one. 14.5 times 1.609, because that's on top, times 24, because it's on top, and then times 7, because it's on top. This one is just going to be multiplication across the board because I didn't really have any numbers that were in the bottom. Okay, so I got 560 with 3 significant figures, so I'll add the decimal point, kilometers over weeks, like that. Okay, and that would be the final answer to that one. So really the only difference when you have compound units that you are trying to convert is that you just separate the units at that initial first point. So here Instead of squeezing everything into that top left corner, I separated miles and hours over the line to make it really easy to cancel out hours later in the problem. Okay, next one. If I was driving at 14.5 miles per hour, how many kilometers would I travel in 28,190 minutes? All right, so this one, the reason that this one is a little more complicated is because I'm given two numbers. I have 14.5 miles per hour, and I have 28,190 minutes. So which one of those do I start with? A very common mistake is to just write down the first number you see in the top left corner of your dimensional analysis, but that's not always going to be the number you're trying to convert. So look at the actual question, what it's asking. How many kilometers would I travel in 28,190 minutes? You have to actually read the problem. What are we trying to convert? I want to change minutes into kilometers. I need to figure out how many kilometers would be traveled in 28,190 minutes. So I'm trying to change 28,190 minutes into kilometers. It's kind of strange because minutes is measuring time and kilometers is measuring distance. So we have to think, how can we convert minutes into kilometers? So the key here is going to be the other number that was given to us, the 14.5 miles per hour. Remember, when you are writing these in dimensional analysis problems, you can write it separated over the line like this. Right? That's how we started the last problem. This is actually how we're going to use this number as well, because when the 14.5 miles per hour is written this way, you can see it's actually set up to be used like a conversion factor that converts between miles and hours. And you could set it up the other way with the 14.5 miles on the bottom and then 1 hour on the top. It doesn't really matter. It's just going to be whatever makes sense to cancel out the units in your problem. So both of those would be acceptable, just depending on what you're trying to get to cancel out. All right, so if you think about it, I can sort of plan this out before I really jump in. Let me at least write down the problem. So I have 28,190 minutes. That's going to be where I'm going to start. The conversion factor that I have, the 14.5 miles per hour, that is going to be the conversion between miles and hours. So in order to actually use that, I have to change minutes to hours first. 1 hour contains 60 minutes. And then once I do that, I can actually change hours to miles using the 14.5. So 1 hour is 14.5 miles. So you can see here, the units cancel out. So minutes cancels out here, hours cancels out here, and we're left with miles so far. So to change miles to kilometers, it's just going to be one more step. Miles down on the bottom, kilometers on the top. 1 mile is 1.609 kilometers. And that would be the setup for the problem. So it'd be 28,190 divided by 60 times 14.5 times 1.609. And I'm going to round that to three significant figures, because the 14.5 that I was given in the problem only has 3 sig figs. And you get, well, this is what it is unrounded. To round that to 3 significant figures, I would actually have to do scientific notation. Like that, right? So that would be the correct answer to that problem. All right, hopefully that makes sense. Let me know if you have any questions.